Network security, IPsec. In this nugget, we'll be taking a look at network security, and we're going to start off with the IPsec topic here. With IPsec, we get a couple of key features there that make it valuable to us. The first one is authentication, so that we can confirm that traffic really is coming from who it says it's coming from. And then we also get encryption, so that we can protect the data on the wire. Also, we'll take a look at the various components of an IPsec policy, what they consist of, and then we'll take a look at practical ways of how to actually configure an IPsec policy. Did you ever see something that you realized later on you shouldn't have seen, or that was perhaps none of your business? I know I certainly have. I remember back when I was a little kid, I was in early grade school and it was Christmas Eve, so of course I couldn't sleep that night. And for some reason I decided to get up and go into the kitchen, and as I came around the corner I saw my mom standing at the kitchen table wrapping a Christmas present. And it was something that really excited me because it was a toy machine gun. Yeah, this was before they became politically incorrect and all of that. But anyway, I was really excited about it, and I finally got myself back to bed, and I woke up the next morning, went underneath the Christmas tree, and I saw this present, and I ripped it open, and it was the toy machine gun. But the package said that it was from Santa. But I saw my mom wrapping that present. So, of course, my worlds collided. I realized that Santa didn't really exist, and it's one of those little disappointments that's taken years of therapy to correct. But anyway, that's one of those things that I probably shouldn't have seen right then, or that wasn't really my business at that particular moment. And we also have people on your network that inadvertently or on purpose and perhaps maliciously might be trying to see things that they really should not be seeing. Business documents that aren't really any of their business, or trying to intercept passwords over the network, things of this nature. I'm a certified ethical hacker, and I've seen many times where we've been able to intercept passwords passed in the clear over the network, or to collect sensitive information, even though that we were not the recipients of that information, but we're able to collect it and analyze it using sophisticated kinds of packet sniffers and things like this. Well, what we're going to be addressing here is something called IPsec, which goes a long ways in preventing those kinds of eavesdropping things from happening. And IPsec is really good for a couple of major things here. One is authentication, and the other is encryption. With authentication, we want to make sure that we have good origination. This means that the data that we're receiving comes from who it says it's coming from, and it's not coming from an imposter. This can be checked a number of different ways by using a shared password, which is not really a very secure method, but it's good for testing purposes if you want to use it for that. And then you can also use a certificate authority. This is especially good if you're using communication between two different hosts that are not in the same Active Directory domain, for example, and you still need a good way to verify each host in the transaction. And you can also use Active Directory's Kerberos authentication, which is what we normally would do within a forested environment for Active Directory. So origination is good. Integrity is also good here, because we want to make sure that this data that we're receiving has not been altered in transit to us, so that someone has not picked it off the wire, modified it for their own purposes, or to maliciously form that packet and then send it on to us. So if someone does touch it and modify it in any way, then it will fail a hash algorithm, and it will be confirmed on our end that someone's fiddled around with that packet. There's also anti-replay. We don't want someone to pick a packet off of the wire, such as something that might have credentials in it or some kind of an authentication packet of some kind, and then attach it to their own data and send it on and try to use the authentication or the authority of the original sender and use it on their own data. Well, that would be a replay attack, where I take someone else's packet, I pretend that it's my own, and then I try to gain access to resources that the original sender could have also accessed. And there's a number of different ways that takes place, but that's called a replay attack, and IPsec is good for anti-replay. And then we can also use IPsec for encryption. This can take place on wired or wireless networks. It's not really a matter which one it is. Early in wireless networking, some people were using IPsec or other equivalents to try to encrypt the data. But there are really good wireless encryption methods that can take place outside of IPsec now, but it's still out there somewhat. In our video here, in our nugget, we're not really addressing it one particular way or the other, but it definitely does encrypt the data if you want it to do that. And the advantage of that will be that even if someone is able to pick it off the wire using some kind of a packet sniffer, they will not be able to reconstruct that data and make any sense out of it. Now then, the way we actually configure IPsec is through 3 different ways. Actually, there's kind of 4, but I'll show you about that in just a moment. One of the first ones is a new tool that's included with Windows Vista called the Windows Firewall Advanced Security, or WFAS is how you'll usually see that abbreviated in Microsoft documents and so forth. So with WFAS, now this is going to be a simple way of configuring IPsec. It doesn't give you a lot of the different configuration options that you would have otherwise, and you'll use some default settings there. But if you would just need to get something configured and secured kind of quick and dirty, pretty good way of going. But it's not really very good for an enterprise-wide method. It's usually pretty good for setting up like point-to-point connections or smaller connection topologies. However, if you need to expand beyond the basic rules that you have with WFAS, you could go to a local policy instead. And that's just where you would go to a start, run, or a start on the start menu down here, where you just click on start. And you can type in here and type gpedit.msc, and that would open up the local policy editor. Within that, you can also go to administrative tools here and local security policy. By the way, you may not see administrative tools on your start menu, but you can right click on the taskbar down here and go to properties and configure it so that it does appear. And both the local policy and this other item that I just showed you, the local security policy here, actually point to the same location in the local policy, so that it's just kind of 2 ways of getting to the same place. And then you can also use a group policy. So if you configured this maybe on an OU, then on a server's OU, for example, then all the servers in that OU would have the IPsec configuration that you've decided to configure there. Another thing, and this is not really an exam issue, but it's something that you might just want to know about. Another issue is that we normally don't configure too many policies on sites. But this would be a good example of where we might want to do that. So for example, here I've got one site. Maybe this is my Dallas site. And maybe this over here is my Phoenix site. Okay. Now in Phoenix, we just have normal, ordinary office traffic. Okay, office network traffic. Just general business kind of things going on. Sure, we have some security measures in place and firewalls and things like that, but it's not, locked down as tight as certain other places like Dallas. Whereas in Dallas, we have high security. Okay, we have very sensitive government contracts or something like that, or working with maybe healthcare information or something like this. Then maybe we want to take it a step further beyond just firewalls and so forth, and encrypt the data, even that is within our own walls and within our own local area networks there. Well, in that case, I might configure an IPsec policy, a group policy object, on a site. And we don't usually do that very much for other kinds of policies, but this is a good example of where we might use a site group policy object. Again, that's probably not an exam issue, but it's one of the things that you might want to know about. Now then, let's also talk about the IPsec components, and then after this, we're going to get into the interface, and some of this will start to make some more sense. But first, let's go ahead and address what the components of IPsec really are. First thing is, you have IPsec policy itself. This is kind of a container. It's a logical container for some other things here. By the way, when I say IPsec policy, I'm not referring to a local policy where you type gpedit.msc and you configure policy there, or I'm not talking about a group policy object. Both a local policy and a group policy object can contain IPsec configuration data, but the word policy here does not refer to either one of these things specifically. Okay, and we'll see that as we go as well. Now, an IPsec policy, like I said, is a logical container for an IP filter list and IP filter actions, or rather filter actions. An IP filter list just simply talks about which hosts it is that I'm talking to. So, for example, when I dial in to my network, maybe I've got an old dial-up networking issue, then when I dial in, maybe I want to secure that using IPsec. Well, then I would configure my RAS server or my client computers to be able to use a filter list that says anytime you're communicating with RAS server 4, then we're going to use these IPsec rules, for example. And then we could also have filter actions. Okay, once we're communicating with that dial-up server or that RAS server, then what happens? Now the filter list identifies the hosts that are part of the policy. Once we've identified them, what do? Well, we take these actions. And that could be simply to authenticate the server or authenticate the client or both, or we could encrypt the traffic that takes place there. And IPsec is very often also, by the way, very useful for data that might be public otherwise. So, for example, certain kinds of data that might take place in the clear that we want to protect. So maybe we want to telnet to our servers. Well, telnet packets are easily sniffed off the wire and could be manipulated or could be read very easily by someone with malicious intention. So we might configure things such that when we telnet to one of our servers, that we always have that set up so that it identifies the server in our filter list, and then once it's identified that server, it says in the actions to go ahead and authenticate both parties to make sure that the traffic is going to and from who it says it is, and then we also want to encrypt that data to prevent it from being easily sniffed. Alright then, let's go ahead and create an IPsec policy. And what we're going to do with this is create it using the Windows Firewall and with Advanced Security. Now, I mentioned earlier there are a number of different ways of doing this. WFAS is one of the ways you can do it on an individual computer basis, but it's probably too much work in the enterprise. For that, we'd probably use a group policy object instead. But if you have just a couple of computers to configure, for example, or a small number, this Windows Firewall with Advanced Security works just fine. Now, notice as we get into this that my firewall's turned off. That's only because I'm using a third-party firewall instead of Microsoft's right now. I will turn this back on when we talk about Windows Firewall in a future nugget. But for now, we're going to go to Connection Security Rules, and I can right-click here to choose a new rule, click this link over here on my right, or we can just right-click in the middle here and choose New Rule. And once we've done this, it's going to start a handy little wizard. This is the most wizard-happy thing you'll ever do, is to create an IPsec policy. But we have a number of different options, which I think if you read the text underneath each one of those, they pretty well explain themselves. But I'm going to create a custom rule just so that you can see many of the available options to you. Now, this is even with the custom rule, it's going to be pretty well streamlined, and there's some default settings that will apply. But at least we'll see more of the settings than we would otherwise if we chose one of the pre-packaged ones. So as I click on next here, it's going to ask us which computers are in endpoint 1 and endpoint 2. Alright then, let's go ahead and take a look at how to actually create one of these IPsec policies. Now the first method I'm going to show you is more for an individual basis, one computer at a time, or a small group of computers, but you wouldn't want to do this at an enterprise level by any means because it's repetitive work. You'd have to do it on each individual computer to some degree. So I'm going to go to Administrative Tools, Windows Firewall with Advanced Security, and select this option, and you will have to know how to do this for the exam. By the way, just as a quick side note, my Windows Firewall is off. That's not normally a good practice, but I have it off because I'm using a third-party firewall, and when I install it, it automatically turns off the Microsoft version. I'll turn it back on, and we'll look at the firewall again in a future video, in a future nugget. Now, here we're going to go to our connection security rules, which is empty at the time. At this time, there's nothing there, so we'll have to right-click here to choose a new rule, or click the link over on the right where my mouse pointer is, or we can just right-click in the middle, hit new rule. Once we've done that, we'll get a few different options. Now, these pretty well explain themselves if you read the text. The basic idea here is you want to control whether you're going to do something like a tunneled connection. This might be the case if I have a public internet connection and I'm trying to make a secured connection to another computer on the other end of that internet connection. Server to server might be useful if I have something like, a website and it's communicating with the back-end order-taking SQL database, for example, and maybe it's got a confidential credit card data or something like that that goes between them. I might do something like that. Also, authentication exemption. Now, with this one, it doesn't really have much use unless I have more than one IPsec policy, because I might have an IPsec policy that says restrict all communications, or it might tightly lock down the communications, but I want to make an authentication exemption. This would be where I want to say, except for this one computer, we want to release it from these authentication requirements. And it might be something like a public kiosk computer that needs to easily communicate or something like this. And then there's isolation, which is where we can only allow connections if it's a member of our domain, or if it's got a good health status. By the way, what's a health status? We don't really address that much in this exam. You'll see it probably more on the server exams for 2008. But this is something called network access protection, such that if somebody's been out of my office for maybe a sabbatical for a month or something like that, or on vacation even, and while they were out in Aruba, they picked up a virus on their laptop, and then they brought it back into the office. Well, I don't want that virus to propagate throughout my environment. So network access protection protection checks to make sure that the virus updates are proper on that laptop, and then it's got the proper spyware definitions and all those kinds of things. And if it does, then it lets it in, and it will be marked as a proper health status. So that's just one of those kinds of things that's new with this current version of Windows. Now, for the custom rule, I'm going to choose that one just so that you can see a little bit more underneath the hood. Most of these other ones are kind of pre-packaged and don't really see much detail with them. So I'm going to choose custom and click on next. And then it doesn't really say here in the interface anywhere, but what we're really creating here is one of the things I mentioned on a previous whiteboard, and that is an IP filter list. In other words, when it identifies computers that I'm going to specify here, then it's going to apply the filter actions to whichever computers are identified. In this case, I'm just going to choose any and any just to make it kind of general, but you could be specific with a given IP address or a range of IP addresses, either IP version 4 or 6, and if I click add, you see some examples of how you can add those, like here's a specific address, here's a IP version 4 subnet range, which would be the whole Class C subnet range of this address. Now we'll talk more about networking and things at a future point in time in a different nugget. Then we could go to an IP address range here as well, like 192.168.0.1 through .25 or something like that. Or a predefined set of computers based upon the kind of role that they have, like a DNS server, for example, or all computers on my local subnet. So I might say on this subnet, we don't want to have any particular authentication requirements. And if I did that, then I would also probably have another rule, or rather another IPsec policy that would be more locked down, so that if I communicate outside of my local subnet, then I want authentication or something like that. And it's very, very flexible. And I'm not saying you should do it that way specifically. I'm just saying that those are the options that we have. And then, oops, I got to specify my endpoint, which at this point is any IP address. And then as we click on next, we see that we want authentication to occur, or when we want authentication to occur. Now, one of the first things that I thought of when I was first working with IPsec years ago, because you've been able to do this kind of thing for a long time now, but one of the first things I thought of was, well, when wouldn't you want authentication? I mean, doesn't that sound more secure to just always use it? Yeah, normally it would be, but you can't always have the luxury of authentication like that. So, for example, you might have people in your organization who are working within your building. Maybe they're business partners of some kind, but they're not part of your domain, so they can't really authenticate in the same way that other people can that also use your network. There's a number of different things like that that you have to consider. Also, it could be a matter of transitioning. You might not have your entire network infrastructure set up to perform the kinds of authentication that you see here, so you might not be able to authenticate in both directions all the time. And they pretty well explain themselves as in terms of when they authenticate or which direction they authenticate, but there's also this one, do not authenticate, and why in the world would you do that? I mean, if I'm not going to authenticate, why even go through the whole wizard here? Well, the reason for that one could be that I might have another IPsec policy in place, which is very, very strict, and I might want to make sure that there is an exception to that for a given group of computers or maybe a given IP address, so that I want one host or a number of hosts to be able to communicate without authentication for one reason or another. So this setting really doesn't have much meaning at all unless you have some other IPsec policy there as well. I'm just going to select the first option there and then click on Next. Once we get here, we see what kind of authentication methods to use, and we'll start here at the bottom. I'm going to click on this again in just a moment and show you some of the customized options so we can get a full scope of things. Here we have a computer certificate. You have to have a certificate authority in place, or you have to have purchased certificates from a known CA. And this would be something like, VeriSign or one of those types of companies. And then these health certificates relate to the network access protection that I talked to you about a little bit earlier. Again, probably not an exam issue for us, but this again would be the thing where you can verify that maybe a computer that's been out of the office for a while, when it comes back in, it hasn't picked up a virus in the meantime, and then it has the proper virus and spyware definitions. Computer authentication, which means that, again, of course, that only the computers that are truly part of our domain and no impersonators are allowed to authenticate. Okay, and then computer and user, which mean both parties would be authenticated by using Kerberos version 5. Again, Kerberos v5 is not strictly Active Directory, but that's mostly how you're going to be seeing it used here. Kerberos actually predates Active Directory, and it's used in other environments, but normally for a Windows environment, that's normally how you're going to see it. And then there's this default one, which is just going to use the user authentication method specified in the profile properties. Now, as we look at that, you might say, okay, What? What profile properties? I'll show you that here when I get to the end. But there is a default set of authentication methods and some various security settings that we cannot see in this interface. You have to go to a different interface to be able to see them. And it's good to know where they are, just in case you need to be aware of that. Now, for our purposes, I'm going to go to advanced. Not that I normally have to do it that way, but just because I want to be able to show you some of the customizable options for first, second authentication and the optional authentications. Now, let's take a look at this. If you just kind of glance at the top, okay, first authentication, second authentication. Okay, the first authentication I want is, and then you click add and you add something in. But the key thing to remember here is that the first authentication is going to be for computer authentication. Okay, the second authentication is for user authentication. And I've seen this taught incorrectly, where they think that this will be the first attempt, and if that fails, then you go to this attempt. That's not what that's about. It can be partially, but that's not really the main thing here. This one's going to be computers. This one's going to be users, okay? And then you decide what authentication method you want, and you can see the ones here that we've discussed in the past. The only one I haven't really talked about is this NT-LAN manager, which goes back to older versions of Windows. Still fairly secure, but not nearly as secure as Kerberos or certificate authorities. And then you saw also a pre-shared key down there. That's best only for testing, just to see if you can make a connection. And then I wouldn't leave that there permanently because it's not very secure. And then for our second authentication method here, again, this would be for the users. So I might even leave this blank, or I might make it optional. So for example, when would we make these things optional? Maybe I've got a user who is sitting at a computer, and the user needs to access the network or access a host, but they're not sitting at one of our computers. But I know that they are a good user account. Well, if that's the case, I might make first authentication optional, so that the computer doesn't quite pass any authentication tests, but as long as the user is okay, then they'll be all right then. In any case, and Microsoft recommends against this as well, you never want to make both of them optional. Otherwise, there's not much point in having this. So this would then, make it available, if we have the settings as you see them here, to allow the computer authentication to be anonymous, whereas the user does have to be authenticated. Also within this interface, as you add things in here, let's just add a couple of things. Let's start with Kerberos authentication, and then I'll click on Add. And maybe I don't have only Active Directory clients. Maybe I've got some older NT-based systems that are capable of NT-LAN management, LAN manager, which is NTLM, and so I could add that in there. So if the computers are not able to authenticate Active Directory-wise, then they can fail over to this method, and then they'll fail over to some other method, a certificate authority, or whatever else I decide to put in here. And these are going to be read from the top to the bottom in order of what's tried first. And if this is the wrong order, of course, you can just switch it with the little arrow keys that we see over here. And then for the second authentication method, I'll just add something in here so we have something to look at. For the second authentication, if I select checkboxes like this, again, you don't want to select both of them, but if I did this type of an item, that would mean that the first authentication, again, would be computer, but if the user authentication does not pass muster with Kerberos here, that's all right. At least we know they're sitting at a good computer, and this will be just optional. If they fail it, too bad, but they still get in. And if they don't fail it, then of course they'll still be able to use Kerberos here. And this, again, is when you simply have to make concessions for what you have within your networked environment in terms of your user accounts, computer accounts, whether or not you have Active Directory, and the like. So I'm going to go ahead and clear all of this out because we're not going to actually use this. So let me remove all of this stuff here. And then we'll go ahead and click OK. Oops, I guess I can't do that. I'll just cancel it. And then we'll go back down here, and I'm going to go back up to our default method for the time being. And then you specify when this rule applies. You can choose domain, private, and public, and we'll, again, discuss this a little bit more when we talk more about networking later on in a future nugget. But we have three main kinds of profiles that we can use, and you'll see this whenever you make a new connection to a network. It'll ask you where you are. Are you in a domain, or a private network, or a public network? And depending on how stringent or how liberal you make that IPsec policy, then you can just selectively determine which one of these you want here as well. It just depends upon your circumstance. So then as we click on Next, that's pretty much it. Then you would just type in a name and a description. That would be it for the new connection security rule wizard that we would see right here. Now recall that I did mention there are certain default values that you can't see in the interface we worked with just a moment ago, but to see them, you'll go to the top of WFAS, go to Properties, And then from here, and we'll talk about these tabs in another video or another nugget when we talk about the firewall settings. But here we'll go to the IPsec settings, choose Customize, and here we'll see the default settings. By the way, let's explain what these various sections are. Key exchange is what's known as main mode in IPsec lingo, and this is where it's going to establish the kind of communication that can occur between the two. It's where a negotiation takes place and where keys are exchanged. Now, these are not the actual keys that are going to be used, but it's keying material that can be exchanged, and it's kind of strange. It's really an ingenious method that can take place, but there's key material that is exchanged between the two hosts, and they both generate the same exact key on their end without actually exchanging the secret key. So it's kind of an ingenious method of working there. Now, then there's the quick mode. This is once main mode has taken place, then quick mode takes place where the data is actually protected, and then that's where your encryption of the data on the wire goes through. And then there's your authentication method, which we've kind of addressed already before. Now, to know what the default settings are, because it doesn't really say right here either, number one, you could go down here to click the link where it says what are the default values. This is a very simple help file which accurately tells you what the default values are. And if you want to see them for yourself or manipulate the default values, just go to Advanced and click Customized. These are the default values. You don't need to memorize all of these, and you don't need to understand the science behind the Diffie-Hellman group, which is the mathematical science that goes into all of this. But for purposes of a Windows Vista exam, I would just say you need to know about 3 of these and just the purposes of them. The Diffie-Hellman Group 1 for backward compatibility. So if you're unable to communicate with other hosts, maybe they're older, maybe they can't understand some of the Diffie-Hellman kinds of things that are further up the chain here, you might need to back it down to Diffie-Hellman Group 1. And then these top 2, just know that these are for Windows Vista and later, which would include Windows Server 2008. And these are very, very strong methods for the key exchange. And that's what Diffie-Hellman does, is it exchanges that key material and allows both hosts to generate a unique key that is the same, and yet that same key is never itself transmitted over the wire because, of course, then it could be intercepted and exploited. And then in terms of the integrity, to make sure that the data has integrity, we use SHA-1 hashes. This is, again, it takes whatever the data is that's there, runs it through a kind of a mathematical blender, and then it should wind up with a unique value. And then on the destination, when it receives the data, it runs it through the same SHA-1 hash, so the math is in common there, and it should wind up with the exact same result. And if it does, then they know that the data has not been manipulated. Also, for encryption purposes, you can use Advanced Encryption Standard, 128-bit encryption, or what we call triple DES here, which is 3 sets of 56-bit keys, and that's a pretty good algorithm here as well. This is all very, very strong, by the way. It's a pretty tough nut to crack if you're a hacker. Oh, and then also here we have the key lifetime in minutes and sessions. By default, 480, so it's 8 hours? Yeah. 8 hours is how long the key will last. And then at 8 hours, it'll regenerate and establish a new key. And that's simply, again, to throw off anybody that's trying to exploit any information that they were able to gather. It takes time to do all of that, so if we change the key every 8 hours, then anything that they have been able to crack in the meantime is pretty much rendered useless. You can also do a key lifetime in sessions, so a number of sessions that are established with this host, and you just enter in a number there. If you leave, actually the default value is there is 0, and 0 means it doesn't have any relativity at all. It doesn't regenerate based on sessions. But anyway, most of that is even more than we really have to know for the purposes of our exam. Again, for the main mode, and then for the quick mode, again, just another look at the kind of thing that we were looking at earlier. Remember, we were in this same interface previously, where we can establish this ourselves if you wanted to do that manually. Then there's the authentication method, which once again we've really already discussed. So that's where we can come up with all of those things. Now let me point something else out here as well. Let me just quickly create a new rule, and I'm just going to default everything through next to finish, just so that we have something to work with here. My IPsec rule. Policy, actually, it would be called policy. Okay, and I'll just go ahead and finish that up. Now, if I spent, weeks of testing and, getting all kinds of brain cramps and took all kinds of Tylenol and stuff like that to come up with this sophisticated policy on this computer, but then I realized we needed to use it on some other computer as well, I don't want to have to go to that computer and create it all again from scratch or recreate the wheel. I don't want to have to write it all down on a yellow legal pad and hopefully, haven't forgotten something. So what I can do instead here is once I've created this, then then what we can do is, let me click on the right things here, what we can do is to go back up to the top node, right click and choose export the policy, and then we just name it as a file, maybe on a thumb drive or a secure location, and then we take it to our destination computer, and then you can choose import from the same right click menu, and then there you go. Then you can just quickly and easily import that. Now this policy is enabled as soon as I go ahead and put it in here, but if I decide that I don't really want it enabled for now, maybe I just put it in there and I'm testing it, I'm still looking at it, then I'll disable that rule and notice that this then turns gray. And then finally, if you find out that you kind of, you've been fiddling around with all this stuff to the point where you're not even sure what you set now, and you can't backtrack enough to safely get yourself back to where you needed to go, you can delete this if you need to, but if you wanted to go another step further and maybe you messed with the default values as well, then you can right-click on here and choose Restore Defaults, and then this will set the computer to be back exactly the way it was out of the box in terms of the firewall settings. You do have to be careful. There is a caution here. You do have to be careful because if you've made some customized exceptions to your firewall, for example, then those could be overwritten here, and that might be against your wishes. And then before I close this interface, let me just point out that creating an IPsec policy within this is going to be a more general way of configuring IPsec. The way I'm going to show you in just a moment here is going to be more specific. Also, by default, you may have noticed that the settings that we have here are by default going to be providing data authentication security. So that's going to be your anti-replay, your origin authentication or your origination, and your data integrity. And by default, there's not really data encryption included in that, although certainly you can configure that here if you want. And then also, you can't be specific in terms of things like ports. With other methods that I'll show you here in a little bit, you can also set up a connection between two hosts that says allow this traffic to pass through, but encrypt it on port 23, which would be a telnet port, or port 21, which would be an FTP port, for example. So it's a pretty good tool, but it's not as specific as some other things I'll show you that you would probably use in the enterprise or in the corporation. So then if you are in an enterprise environment, or if you want to be more specific about the local policy here, then the interface is going to look almost exactly the same. All I have to do is to edit the policy. So whether it's a local policy object, which is gpedit.msc, and I can just type that in where I am right now and access that, or if you did it on a group policy object in Active Directory, either way the interface would be the same. Or if you went to administrative tools, and you went down here to, local security policy, this really just cracks open the security section of a local group policy or a local policy. So in the interface items, this is where you would find that data, and it would be right here for IPsec policies on the local computer. I am going to just go ahead and go with the gpedit.msc because that'll hold the most things in common in terms of whether it's the enterprise-wide view with a group policy object, local computer policy. They both look exactly the same. And then if we go down here into the Windows settings, security settings, this is exactly the same settings that we would have seen in the last window that I opened up, which was our security settings. So here I'm going to go ahead and go down here to the IPsec policies on the local computer. Notice that I can create an IPsec policy, manage IP filter lists, and filter actions. Now then, for our purposes, I'm just going to right-click to create an IP security policy. Now, once you've got this thing rolling and you've got a few different policies created and so forth, then you'll have a filter list and a filter actions. If you don't have any yet, and I'll just click here, you can see I don't have either one right now. But if you don't have any of that, when you create the IP security policy, it launches two other wizards to create a filter list and to create a filter action. In fact, this wizard right here is the first of three wizards. So it's kind of a wizard inside of a wizard inside of another wizard. It's pretty wizard happy here. And then you can just create a policy of any given name. I'm just going to leave this as the default for the time being. And then we just click on Next, and then you can activate the default response rule if you want. Now this doesn't really apply to Windows Vista, because the default rule already appears in the default settings that we looked at a little bit earlier. This is going to apply to only earlier versions of Windows, so it's not really relevant for our purposes. But once you click on Next, then you want to go ahead and click on Edit the Properties here, which is set by default, so that's going to launch another wizard. And then when we click on Finish there. So this is the default response rule that we don't really use here anymore. If we wanted to have a different rule, then we'd click on Add, and that launches our second wizard. Here's where I would then select what kind of a rule I'd want to create. And what this is talking about is whether or not we're using tunneling. This is used in virtual private networks where we want to have a secure connection set up between two hosts on what would otherwise be an unsecured connection, such as the internet or certain WANs and the like. We could say it does not specify a tunnel, or if we did have a VPN or some other method that we wanted to secure differently, then we could do the tunnel endpoints here and enter in the IP address of those endpoints. But we'll say that for our purposes it does not specify a tunnel. And then we could say that we want to have this apply to all network connections or only LAN connections or RAS connections, whichever way you wanted to go. I say RAS, that's remote access. It's kind of the shortened way of saying remote access services that we've said in the past. So I'll leave it at all network connections. And as I click on next, then I'm going to enter in my filter list. Here's going to be the IP addresses, the ports or the port ranges, all those sorts of things. And as I click on add here to add a different item in, notice that it launches yet another wizard. So then I go through here and I can enter in a description if I want as well, and it'll also be mirrored. Now mirror just means exactly what it says here. It's going to match the exact opposite source and destination address, so that not only does it secure outbound traffic, but when that traffic comes back through, it's just going to reverse the settings for the incoming traffic, so they don't have to manually create a second item here as well. And then as we click on next, we specify our addresses. It can be any address, or a specific DNS name if we want to do it by that, or IP address and subnet, so we can enter in an IP address or subnet here as well. So I'm just going to leave it at any, but you can see the number of different options here that are also available to us. And then your destination, again, you can choose the same types of options here as well if you like, and I'm just going to leave it that way for the time being. And then here's where we could go a step beyond what the WFAS allows us to do, and we can specify which protocol we're using. Almost always we're going to use TCP for this kind of a situation, and then this again is another step forward where we're going to make more settings here than we can in WFAS, where we can specify a port 23 or a port 21 or whatever it is that we want to do. Okay, so I'll say, maybe we're only trying to secure telnet traffic on TCP 23. So then that's what I would select there. Then as I click on this, I can choose Edit Properties, and this just allows me to look at the properties of it without going through a wizard. And then if I click Finish here now, it lets me see the IP filter properties, and I can make modifications if I want to, and so forth. So just another way of being able to work with this. Okay, and then again, our protocols and our description, which we can fill in as well as if we want. And then as we click OK here and click on Next, then we'll have, we got to select something first, so I'll select that as a radio button item that I want to work with. Then I'll click on Next, and now here's my filter action. So the previous screen, I chose my filter list, in other words, which IP addresses or which servers it is that we want to configure an action for. This is going to specify what happens then when we establish a connection as desired. Here I'll use again a wizard, so yet another wizard gets launched, and then we'll go ahead and click on Next through this to where I'll put in my filter action. And here's what I'll do then. I'll either permit the traffic, I'll block the traffic, or I'll negotiate security. Of course, I would choose block the traffic if I was trying to lock down a server. Maybe I didn't want anybody to communicate with it. And then if I did that, the server wouldn't have much purpose in life unless somebody could communicate with it. So in that case, I would set up a second policy here where I would negotiate security. And I would say only these computers can then communicate with it. And with IPsec rules and policies, the more specific will take precedence over the more general. So if I block everybody with one policy, but I allow, these 3 computers with another more specific policy with their IP addresses in it and so forth, then this would be the one that would rule. So to negotiate the security, then that's where we'll actually get to our individual settings, and I'll specify whether I want kind of a failover method here. So I would say do not allow unsecured if I didn't want that to happen at all, or the failover would be allow unsecured if for some reason they're not able to establish a security connection. Then we'll use a failover to whatever else we want to use. But I'll say do not allow an unsecured connection for our purposes, and then we'll see that the filter action requires at least one security method for IP traffic, and we can choose integrity and encryption. That's again the data integrity for data integrity, origination, and anti-replay protection. And then the other one there would be the encryption again, which encrypts the actual data itself over the wire. I can also do integrity only, but the data won't be encrypted in this case, but at least I can be sure that it's the data is not being tampered with or something like that. And then if we go to the custom settings, you'll see certain things that we've looked at in the past. This is where I could set up my data integrity and encryption. This is the encapsulating security payload. This would provide both functions for me. I could get by just fine with this. If I wanted an added level of data and address integrity without encryption, then I can also specify what we call authentication header here. So this is kind of a double layers of the integrity here that we could go. So integrity here, and then we would add encryption if we checked both of these boxes. Very often, we don't necessarily need AH because we already have that data integrity included with ESP. And then we could choose our integrity algorithm using different hashes there if we want to, and then different encryption algorithms as well. And as I mentioned in a previous screen that we looked at earlier on here, we could generate a new key every certain number of kilobytes, or generate a new key every certain number of seconds here also. So I'm just going to go ahead and cancel this. I'll leave the settings here at the integrity and encryption. And then, once again, once you're done, if you want to look at the property dialog box to kind of review your settings, certainly you can do that, and that's what we've got here. And now then here I've closed all the windows up, and we now have the new IP security policy, if you OK all the settings. Now this does not actually turn on by default. I have to right click and choose assign, and when I do that, the icon will change over here, you'll see, to a green dot. That means that this security policy is now applying. I can also unassign that to reverse that setting. And then, of course, if we want to delete it, we'll simply right click here and choose delete, and that's pretty much it. We just click yes, and there it goes. In this nugget, we talked about network security, where we specifically talked about IPsec, which is an excellent way to both authenticate and encrypt your data. Remember, our authentication verifies that the network communication is actually coming from who it claims to be coming from, and we have very secure methods for being able to do that. Principally, we're going to be using Kerberos or a CA, a certificate authority, to do that. And then the encryption is also very tight, and it's very useful so that someone cannot sniff traffic off our wire and pick apart passwords inside of our packets and so forth, because they'll be encrypted, and it's very, very tight encryption. IPsec overall, very, very secure way of going. We also took a look at the various components of an IPsec policy. Remember, in an IPsec policy, it's really a container for an IP filter list and filter actions. If something matches the filter list, then it will perform whatever is in the filter action. Remember also that if you have more than one policy, the more specific policies will take precedence over the more general ones. And then we also took a look at how to configure this. Remember, with WFAS, we use the connection security rules, which is just another way of talking about creating an IPsec policy, although it's not quite as full-featured as if you used one of the latter methods that we looked at, which would include the local security policy, which you can access from administrative tools on the start menu, or you can also access through the local policy editor, or what you can also do, if you do it on a domain-wide or an OU basis, you can do it through a group policy object, but again, the interface looks exactly the same for all of those. Well, I hope this has been informative for you, and I'd like to thank you for viewing.